Once again, welcome to my channel. Today talk about interior of the earth, and this lecture also unit 1 geomorphology of the syllabus NTA NET, and also MA/MSc and BA/BSc geography student, and very interesting topic for our NTA NET geography, and must will listen my complete lecture carefully. And there are the many lecture in my channel such as the NTA NET geography related, and the most of the documentary video also available. And must will, if you are new, must will subscribe and click bell icon. So now start my topic today, interior of the earth. First of all, the structure and composition of the earth, and the interior structure of the earth is made of three main cells, the very thin and the brittle crust, the mantle and the core. And there are the furthermore the mantle and core are each divided into two parts, and the core and mantle are equal the thickness, but the core of the earth only occupies 15% of the earth volume, and where the mantle occur 84% in the crust occupy remaining 1%. And this is the cross section of the earth. There are the crust, mantle outcore, and the solid inner part. And the source of information about there are the interior of the earth. And the earth is radius is 6370 kilometer. It is the rather difficult to make observation or collect sample of the material from inside of the earth due to it is huge size and the changing nature of it is the natural composition. And only a part of information is obtained through the direct observation and analysis of material, and most of our understanding about the interior of the earth is based on estimated and the inference. And there are the direct source information, very important in my topic today. There are the direct source of information. First of all, talk about the surface rock. The surface rock are the most readily available solid earth material to make direct observation and laboratory experiments on surface rocks and minerals, and provide important information about the interior of the earth. And next I talk the mining. Mining is basically the rocks that we get from the mining area are another source that give us information about earth interior. And though the mining and drilling operation we have been able to observe the earth interior directly and only up to depth of few kilometers, and world's deepest mining is limited only to the deepest of the fewer than 5 kilometers, and going beyond this depth is not possible due to excessive heat at this depth. And next I talk about deep ocean drilling project. The scientists have undertaken there are some major projects to penetrate the surface of ocean to access the condition in the crustal and portion. The deepest drill at Kola in the Arctic Ocean and has so far reached a depth of 12 kilometers, and these are many deep drilling projects have provided a large volume of information through the analysis of material collected at the different depth. And today there are the volcanic eruption, this very talk about, and the volcanic eruption form an important source of obtaining direct information and through the laboratory analysis and of the molten material, and that is soon on the surface of the earth. And during the volcanic eruption, however, it is difficult to find out about the depth of the source of such as magma. And this is the all above the source. And next I talk about indirect source of information. They are very important. There are the indirect source. And first of all, meteors. Meteors are bit of interplanetary material falling through earth and atmosphere, and the heated and the increasing and the incandescence of friction. And Meteors that at time reach the earth are an important source of information about the interior structure of the earth, and although the material that become available for analysis from the meteors and do not form the part of the interior of the earth, and they provide valuable information as the structure observed in the meteor are the similar to the earth. And talk about the gravitation. Gravitation, the reading to the gravity at the different place is influenced by many factors. There are the distribution of mass, distance from the center of the earth, and such as the difference is called the gravity anomaly. And the gravity anomaly gives us information about the distribution of mass of the material in the crust of the earth. And magnetic field is very important on this source, and the magnetic survey provide information about the distribution of magnetic material in the crystal portion, and thus provide information about the distribution of material in this part. And seismic activity, and the seismic activity is one of the most important source of information about the interior of the earth. Seismic wave, they are P wave, primary waves, they are longitudinal wave like sound wave in which movement of particular in this direction of propagation of wave, it can travel through all medium, they are solid, liquids and gases. And next there are the S wave, secondary wave, and transverse like light wave, and movement of particles is at right angle to the direction of wave, and they can travel through solids only and disappear in liquids. And this is the L wave, basically long waves, also called surface wave, and travel along the surface of the earth and moves particles in a circular path and of two step. And the body wave and generated by and the earthquake, and especially S wave, and which travel only through there are the solid material, have helped in the understanding the interior structure of the earth. And now I talk about there are the different layer of the earth, and the earth interior is divided into basically three layer, crust, mantle and core. And now I first talk about the crust. Carefully listen for our NTA NET Geography student, carefully listen some point to point I explain, and very listen carefully. There are the crust basically due to its accessibility, it is the geology has been widely studied, and so we have a good understanding of the structure and composition of the crust. And the crust is the outermost layer of the earth, and it is brittle in nature. And sometime there are net question, assertion and cause, very important question sometime about the interior of crust. So carefully listen. And the crust of the earth has two distinct types. There are the continental crust and oceanic crust, and these two types have different chemical composition and the physical properties, and were formed by the different geological process. Next, the thickness and density of the crust vary under the oceanic and continental area. Next, there is the oceanic crust is thinner as compared to the continental crust. And the next important, the mean thickness of the oceanic crust is 5 km. The mean thickness of the continental crust is around 30 km, and it is much thicker in the area of major mountain range and extending up to 70 km in the Himalayan region. And next important talk, there are the oceanic crust is denser as the compared to the continental crust, and continental crust has the mean density of 2.7. It is the mainly composed silicon and aluminum, and therefore it is often termed as Cl. And the mean density of the material in oceanic crust is 2.9, and it is the mainly composed of basaltic rocks. And the crust make up about 1% of the earth volume. You must carefully listen. The crust make up about 1% of the earth volume. All above is very important characteristics of this layer. And next must will carefully listen about mantle. Very point to point I talk. There are the mantle. You know, for when you will exam, there are the NT must so carefully listen. The mantle basically our your knowledge of our upper mantle and including the tectonic plate is the derived from analysis of earthquake and heat flow and magnetic gravity and study and laboratory experiment on the rock and minerals. And the portion of the interior beyond the crust is called the mantle. The mantle extends from Mohorovic discontinuity to the depth of 2,900 km. It has and the average density higher than that of the crust. This is the 3.4 gram bar phi cubic, and the mantle is divided into the upper and lower mantle, you know. And when you will explain, when you will talk, when you will learn the mantle, must there are the asthenosphere and lithosphere, and so there asthenosphere, the upper portion of the mantle is called asthenosphere and extending up to 400 km. The word astheno means weak, and it is the main source of the magma that find its way to the surface during volcanic eruption. It lies below the lithosphere, and about the lithosphere, the crust and the uppermost part of the mantle are called lithosphere. It is the thickness range from the 10 to 200 km. The lithosphere is subdivided into tectonic plates. And there are the next important, the lower mantle extend beyond that asthenosphere, and it is the solid state, and major constituent elements of the mantle are magnesium and silicon. Hence this layer is termed as CIMA, and the mantle make up about 84% of the earth volume. Very carefully listen, the mantle makes up about 84% of the earth volume. And next I talk about the core. The core, basically the core, the earthquake wave velocities have helped in the understanding the existence of this core of the earth. And the innermost layer surrounding the earth center is called core, and which is the about 3,500 km in radius. The core mantle boundary is located at the depth of 2,900 km. The core consists of the two sublayer. The outer core is in the liquid state, while the inner core is in the solid state. The core is the dense set layer of the earth, and the density of the material at the mantle core boundary is around 5 gram per cubic, and there are the center of the earth is 6,300 km. The then density about around 13, and the core is made up of very heavy material, mostly constituted, and there are the by nickel and iron. It is the sometime referred to as the fine Nephi layer. Basically the core make up about 15% of the earth volume. Carefully listen, the core make up about 15% of the earth volume. And next I talk about the seismic discontinuities. There are the some discontinuities very important for NT. Carefully listen. There are the seismic discontinuities add to the distinguishing division of the earth into the inner core, outer core, lower mantle, upper mantle, and the crust. Such as the number 1, Conrad discontinuity. Conrad discontinuity, it refers to the horizon between upper crust and lower crust. Carefully listen, Conrado discontinuity, it refers to the zone between upper crust and lower crust. Next very important, Mohorovic discontinuity, also called as the Moho discontinuity, is the zone that separate the earth and the crust from the upper mantle. It can be detected by the surf increase downward in the speed of the earthquake wave there. So it is very important, must we listen. And next there are the rapid T discontinuity. It is referred to the zone between upper mantle and lower mantle. Carefully and must will remember the rapid T discontinuity. It is referred to the zone between upper mantle and lower mantle. And next there are the important Gutenberg discontinuity. Gutenberg discontinuity is referred to the zone separating the lower mantle and from the core. Lower mantle from the core is called the Gutenberg discontinuity. It is located at the depth about 2900 km. Next there are the very important Lehman discontinuity. Lehman discontinuity is referred to the zone separated solid inner core from the liquid outer core. This is the very important, the zone spreading there the solid inner core from the liquid outer core. These are called Lehman discontinuity. And this is the picture. There are the different discontinuity in my lecture. And next very important, I talk about the temperature, pressure and density of the earth interior. What is the temperature, pressure and the density of the earth interior? There are some very characteristics. There is the temperature increase toward the center of the earth, and however the rate of increase of temperature and is not uniform from the surface toward the earth center. It is faster some of the place than the outer. The temperature at the center is estimated lies whenever between the 3000 degrees centigrade and 50,000 degrees centigrade most probably, and such a high temperature inside the earth may be due to chemical reaction and under high pressure condition and the distinction of the radioactive elements. And the pressure also increase from the surface toward the center of the earth due to huge weight of the overlying rocks, and due to the increase in pressure and presence of heavier material towards the earth's surface center, the density of the earth in the layer also goes on increasing. The material of the innermost part of the earth are very dense, and this is the complete. There are the interior of the earth crust, and this is about all different type aspects, and I talk about the different layer and their temperature and the pressure and density of the earth interior and discontinuity. Very important, must will watching. And there are the different lecture in my channel about NT NET geography according to syllabus. Thank you to all.